Alright, so this is Wiley homework number 6A. And what does it say? Okay. So sick. Okay, so they say, what are, yes, you can see it. What are the masses and structure of the ions produced in the following cleavage? Okay. In the following cleavage pathways. Alright, what else? They say all structures should be drawn with no bonds between carbons and hydrogens. Alright, blah. Okay, once again, if this is not 100% clear, by tonight I'll be putting these up in the organic chemistry study group page, so you'll be able to look at the images a little bit better. Okay, so this is, we're going to do A first. There's a bunch of them on here. Alright, so it says a cleavage of 2-methyl 3-hexanone. It's a ketone, right? And it says 2 pathways, which I don't know exactly what they meant by that, but whatever. Alright, so here's our molecule. It's a hexane molecule. Here's the 2-methyl 3-hexanone. There's the ketone. Okay, so I just looked up what an alpha cleavage is because I didn't know what that meant at first. And it is a breaking of C to C bonds next to specified functional group. Okay, so obviously the specified functional group is the ketone, and I got this information from Wikipedia. Just search alpha cleavage. So it was interesting, the example that they gave in Wikipedia was for a ketone. So here they have R1, R2, and this is prior to fragmentation. This is, the molecule's just been struck with an electron, and it forms, the R1 is the fragment that broke off, and then the R2 remained with the ketone to form this molecule. Alright, okay, another piece of information about solving this problem is that Wiley also told you, so they gave you the molecule, but then they also told you the neutral radical that was left over after cleavage. So the neutral radical is positive, no, this is like plus addition, it's not a positive. Radical C3 H7, right? Alright, so before I solved it, I had to look up some background information to help me really understand how to solve this problem. Alright, so background info. I got this from page 432 in the Solomon's and Friel Organic Chemistry book, which is a book we use at John Jay. Okay. Okay, still going. Alright, so I looked up, what did I do? I looked up, let me just see what it's about. Let me just see something. This was fragmentation to form resonance stabilized cations. Okay, so I didn't write that in. This is like a little side note that we should know what we're doing here. This background information that we needed to learn about to solve this problem was, it's section 9.16c, page 431, and it's called fragmentation to form resonance stabilized cations. Right, so what did this say about the fragmentation to form resonance stabilized cations? So it says carbon to carbon bonds next to a carbonyl group, right? Which is what we have right here. The C bonded to double O is carbonyl. That's a carbonyl group. So carbon to carbon bonds next to a carbonyl group of an aldehyde or ketone break. They break readily because the resonance stabilized ions called acylium ions are produced. Right? Okay. So there's a mechanism that they show, an example, and let's go. The mechanism's on the other page. This is to the mechanism, to the acylium ion. Okay. So we have a carbonyl group attached to two R's, R and R prime. And, okay, so the carbonyl group, I don't know why this doesn't seem to be as clear as it was. Alright, so then there's two pathways that this is going to like break into. So this is pathway 1 and this is pathway 2 over here. So let's do pathway 1. So this is, it's ionization, right? That's when we shoot it with an electron and then it loses one of its own electrons. And so we're left with this. We have the R still connected to the R and the R prime. and the electron was lost from the oxygen atom because it's most easily lost from there. So the positive charge is on the positive charge is on the oxygen. And then here what's going to happen is that it's going to fragment on the R arm rather than the R prime arm. The bottom one is the R prime arm. So this electron comes here. This electron goes up here to form the neutral, what's it called, radical. And then this oxygen gives its electron here as well. So this was pre-fragmentation, right? This was the M plus, that's what this is. The M plus with the little dot on top. This is the pre-fragmentation. Why is this so? Alright, so then, right, so it fragments. Fragmentation. Okay, this was by that first pathway that we were going. And we get, when it fragments, the top R went off and the R prime left. No, the R prime stayed. So we were left with R prime attached to C, triple bonded to O, which has a positive charge on it, plus the neutral radical. And then it's stable because it has resonance structure, right? The double arrow like that, the resonance structure. And the resonance structure is that R prime attached to a positive, a carbon cation. I can't remember what it's called right now. Here the carbon is triple bonded to the O. Here the carbon is double bonded to the O. So the positive is on the carbon here rather than on the oxygen up here. So there's resonance. And this is called the acylium ion. Alright, so then that was the one pathway by which this whole mechanism could happen. But there was a second pathway, so this was the second pathway. So again, it's ionization. You shoot it with an electron, and it loses an electron. And so now we have that same setup, the R on top, C, the R prime on the bottom, double connected to the O, which the O is the one that lost the electron because it's the most the most loosely bound. Electrons that are not in a bond are the most loosely bound, so they're the most easy to get rid of. And so what happened was, now this time the R prime took an electron to form a radical, and then one of the electrons from this bond went up here to this bond, and then oxygen gives one of its electrons to this bond, and that causes fragmentation, right? This is fragmentation. This is the second row. This is fragmentation for the second row. And then, so here we're left with the R, which was the one on top, right? The R to the C, double bonded to the O, positive. And this time it's, we have that plus the R prime radical. So over here it was, we were left with the R prime radical attached to the molecule, and we had just the R radical, and here we have the R attached and we have the R prime radical. And again, this molecule has resonance, which makes it more stable, and that gives us R, C, O, and then acylium. I guess, yes, this would be formed, this bottom one would be formed by these two electrons from this third bond coming up and going here to oxygen, and that would form the bottom. Alright, so that was the background information that I needed to answer the question. So now I'm actually going to try answering it.